Hey everybody, Trey here. Welcome back to another video. If you recall, back in early March, we put out a video detailing some of the background factors that modulate tornadic activity in the US, and we made an actual forecast for tornado frequency and distribution across the US for the spring months, March through June. Well, when I uploaded the recap video showing how our spring forecast fared, a lot of you asked if I could do one for the fall and winter secondary tornado season. And that's exactly what we're going to do in this video. We're going to review some of those modulating factors and how they impact tornadic activity in the US during the fall and winter months, and we'll discuss what we might see in the months ahead, focusing on that October through February timeframe, that fall and winter secondary tornado season in the US. We're not going to go as in-depth as in our spring forecast video, but we will at least give you a general idea of what might happen given the state of the background pattern in the months ahead. So, without further ado, let's go ahead and get started. Just a couple of notes before we dive in. Again, I'm going to be focusing on that October through February time frame, which encompasses the fall months, October and November, when we often see a secondary peak in tornadic activity in the US, and also the winter months, December, January, and February, which is typically considered the tornado off-season, so to speak, but in the last few years that has been anything but the case. And again, I'm going to be looking at tornado frequency and distribution across the U.S. for these months. We're not going to look at the potential for hail or damaging wind. We're going to be focusing on tornadic activity only in the U.S. for that October through February timeframe. And as always, I'm going to put links to any journal articles I discuss in this video in the description box below so that you can do some research on your own. So just to provide some context of how this year has gone tornado-wise across the U.S., we are a bit above average as we head into the fall season. The black line here is the average tornado report count for the year, and the red line is our current tornado report count for 2023. And you can see that red line is well above the black line as we start September. As we discussed previously, we had the most active start to the year we've ever seen before a little bit of a lull in April and May. Things revved up again in June and continued throughout the summer with multiple notable tornado days. Both June and August came in above average for tornado count across the U.S., with August seeing nearly double the normal amount of tornadoes for the month. July was no slouch either, coming in right at the 1991 to 2020 average. One of the main modulating factors of seasonal tornado activity in the U.S. is climate teleconnections. Basically how things like sea surface temperatures, where highs and lows set up across the globe, how those things impact the weather on the home front here in the U.S. And the main one we talk about is the El Niño Southern Oscillation, or ENSO. As a quick refresher, ENSO involves sea surface temperature anomalies in the equatorial Pacific, so that region of the Pacific Ocean that lies right along the equator. If those waters are warmer than normal, then we're considered to be in an El Niño phase, and if those waters are cooler than normal, we're considered to be in a La Niña phase. And the specific ENSO phase that we're in tends to modulate the amplification and positioning of the upper level jet stream, as you see here. In a wintertime El Niño phase, which is on the top panel, the jet stream is generally a bit less amplified and shunted farther to the south, yielding generally wetter and stormier conditions for the southern U.S., whereas in a wintertime La Niña phase, which you see on the bottom panel here, that jet stream tends to be much more variable, meaning more amplified waves within the main jet, and generally wetter and stormier conditions farther north than in an El Niño phase. So you can see how this might impact the potential for severe weather, including tornadoes across the U.S. A more active and amplified jet stream generally means more active severe weather conditions farther north during a La Niña phase, whereas a more muted jet shifted farther south during El Niño conditions means that severe potential often decreases and is confined to the far southern U.S., generally those areas adjacent to the Gulf of Mexico. These findings have been supported by numerous research articles, including Allen et al. 2015 and this article by Cook et al. 2017, which looks at how ENSO phase impacts tornado outbreaks in the winter and early spring in the U.S. And they found that tornadoes and tornado outbreaks are much less frequent during El Niños when compared to La Niñas. In fact, the tornado count during January and February when La Niña conditions are present is approximately 2 times greater than that of January and February during an El Niño. Using their figure 3, we can see these trends, as well as that southward shift in tornado potential during El Niño phases versus La Niña. Figure 3A here shows normalized tornado counts for the month of January for each ENSO phase. El Niño is on the top left, La Niña on the top right, and you can easily see the difference. Much higher values concentrated much farther north in La Niña Januaries versus El Niño Januaries. In El Niño Januaries, that maximum hugs the Gulf Coast, extending from East Texas into Louisiana and Mississippi, while it's focused much farther inland with much higher values concentrated from Arkansas into Tennessee and Missouri, even dribbling into the Midwest a little bit in La Niña Januaries. The same trends exist for February as well. As shown in figure 3b here, those maxima hug the Gulf Coast during El Niño Februaries, and we even have a new maximum appearing in central Florida, whereas again, higher values spreading much farther northward in La Niña Februaries. They also determine that La Niña periods tend to foster stronger and longer-lived tornadoes within outbreaks than in El Niño periods. And as Cook et al. Suggest, all of this can be attributed to the changes in the background environment that occur among these phases. During an El Niño, your jet stream is less amplified and much farther south, extending from northern Mexico and Texas through Florida, which means that your surface cyclogenesis or surface low development is going to be weaker and farther south as well. In turn, your low-level jet is weaker and farther south, and your instability axes or warm sectors don't make it quite as far inland as in La Niña phases. So overall, your background environment just tends to be much less favorable and more confined in El Niño phases versus in La Niñas. So what about our current and forecast state of ENSO going into the next few months? Well, here's a map of current sea surface temperature anomalies across the globe. The yellows, oranges, and reds represent warmer than normal sea surface temperatures, and the blues and purples represent cooler than normal sea surface temperatures. And you can see that the waters in the equatorial Pacific are quite a bit warmer than normal, and it's been that way for quite some time now, meaning that we are fully entrenched in an El Niño phase. We started off the year in a La Niña phase, as you can see on this chart of Oceanic Niño Index, or ONI, which is basically just a 3-month running average of sea surface temperature anomalies in the equatorial Pacific. But that quickly changed as we headed into mid-spring, when we rapidly transitioned from a La Niña into a neutral and eventually into an El Niño phase, which is where we sit heading into the fall. And we're expected to remain in an El Niño phase through at least the winter and probably the start of spring next year. In fact, here's the latest ENSO forecast as of August from Columbia University, showing where we are now and where a bunch of different climate models expect us to be down the road. On the vertical axis is the average sea surface temperature anomalies in the equatorial Pacific, and on the horizontal axis is time. And you can see that we start off very much within the El Niño range. This point right here is the observed average sea surface temperature anomaly for July for the portion of the equatorial Pacific that modulates ENSO. It's about a degree or so above normal. And a lot of the models have this increasing before roughly peaking sometime in late 2023 or early 2024. This line right here is the November, December, January timeframe. And many of the models spike above 1.5 or even 2 degrees above normal, which is considered a strong El Niño. And this chart from the Climate Prediction Center shows the probability of each ENSO phase happening going into next year for each 3-month running period. So August, September, October, September, October, November, December, and so on and so forth. The vertical axis represents the percent chance of each phase happening, and the horizontal axis represents time. The orange bar is for El Niño, and you can see that we are maxed out for the foreseeable future. 100% chance of El Niño for the next several months, at least through that November, December, January timeframe, with continued extremely high probabilities above 95% through that January to March 2024 period. So what does this mean for tornado activity in the U.S. in the upcoming months? Well, as we just talked about, El Niño tends to shunt that jet stream much farther south, providing areas adjacent to the Gulf Coast, such as Texas, Louisiana, Mississippi, Alabama, Georgia, Florida, the best shot at seeing severe weather, including tornadoes. And the overall environment for tornadoes tends to be somewhat less favorable, less unstable, less sheared thanks to a more muted upper-level jet stream and associated weaker low-level response. So you might expect that we would see a generally below-average fall and winter for tornadoes across the U.S., with the best chances being down along the Gulf Coast. But there are some factors that may compensate for this strong El Niño. In their 2021 paper, Nouri et al. Discussed how another climate teleconnection called the Pacific Decadal Oscillation, or PDO, ties into tornado activity in the U.S. The PDO involves sea surface temperature anomalies in the interior North Pacific, as well as, less importantly, along the Pacific coast of the United States. If sea surface temperatures are cooler than normal in the interior North Pacific and warmer than normal along the Pacific coast of the U.S., we are in a positive PDO phase, as you see on the left here. And if the opposite is true, we are in a negative PDO phase, as shown on the right. Nouri et al. Discuss that a negative PDO is linked to increased tornado frequency across the U.S. versus a positive PDO due to favorable alterations in the jet stream. And if we take a look at our map of global sea surface temperature anomalies, even though we do have slightly warmer than normal waters along the Pacific coast of the U.S., the waters in the North Pacific are significantly above average, representing a strongly negative PDO. And our time series of PDO data shows that we have been in a strongly negative PDO phase for quite some time now, and this will likely continue into the foreseeable future. And we talked about this in depth in our previous video, but the sea surface temperatures in the Gulf of Mexico, which is our moisture source region, can also modulate tornado activity in the U.S. Very intuitively, and as articles such as Molina et al. 2018 and Childs et al. 2018 suggest, if Gulf of Mexico sea surface temperatures are warmer than normal, the air mass above those Gulf waters is warmer, meaning that it can hold more moisture. As a result, this air mass is more unstable, and as it's pulled northward along the low-level jet in given events, it can provide a more favorable, juicier air mass for tornadic activity to work with. Well, as we zoom into our western Atlantic sector here, you can see that our Gulf of Mexico remains quite warm as we head into fall. Sea surface temperatures are still well above normal for the Gulf of Mexico, for the entire Gulf of Mexico, and that has persisted from the spring into the summer and now into the fall. We've seen that Gulf really stay quite a bit above average, which could mean, again, juicier air masses that can be more efficiently transported northward into the U.S. for these severe weather setups to work with. There is also another piece that could become a factor. Childs et al. 2018 determined that another climate teleconnection called the Arctic Oscillation, or AO, has a notable impact on tornado activity during the cold season, which they deem to be November through February. The Arctic Oscillation involves a belt of flow that circulates around the Arctic, generally at about 55 degrees north latitude. During the positive phase of the Arctic Oscillation, which you see on the left here, those winds are stronger and thus keep cold air confined up here in the Arctic, meaning less cold air intrusions down into the U.S. Whereas in the negative phase, these winds tend to weaken, which you see here on the right, allowing for cold air to seep much farther south into the U.S. So as you might have guessed, the positive phase of the Arctic Oscillation is much more favorable for tornadoes across the U.S., as the stronger winds surrounding the Arctic coincide with a higher pressure over the Arctic, yielding a stronger, more northward shifted jet stream that confines colder air farther north, meaning warmer falls and winters in the U.S. Now, the impact the Arctic Oscillation will have on this year's fall and winter tornado season is still up in the air. Unlike ENSO or the PDO, the Arctic Oscillation can change phase on a monthly or even on a weekly basis, as you can see in this time series of Arctic Oscillation data going back to 2016. We just don't know how the AO is going to evolve over the next several months, so we're just going to have to keep an eye on it. We have been in a slightly negative phase for the last few months, so if that keeps up, that could have implications on how much cold air seeps down into the U.S. this fall and winter, and in turn have implications on the tornado count in the U.S. this fall and winter, but we're just going to have to wait and see. All right, let's get into some current forecast products for the upcoming few months. So to start out this fall season, of course, the fall equinox is about a week away. We're keeping an eye on a potential return to severe weather across the central and southern plains. Some models, such as the European Model Ensemble, which you see here, are hinting at some troughing developing over the western U.S., coupled with ample moisture return across the plains by this coming weekend, around the September 23rd time frame or so. Of course, we're still about a week out, so nothing is set in stone yet, but we could see some severe weather activity early on in this fall season. Now beyond that, let's take a look at the Climate Prediction Center precipitation outlook for each 3-month period through February 2024. Of course, this does not explicitly forecast severe weather, but it at least gives us a glimpse into areas that could see above average precipitation during this time frame, which may or may not involve severe weather events. So for the October, November, December timeframe, which you see here, the CPC is forecasting above average precipitation for the southeastern quadrant of the country, basically from South and East Texas up through the Gulf Coast and into the eastern seaboard, with the greatest probabilities for above average rainfall centered on Alabama, Georgia, northern Florida, and into the Carolinas. This continues into the November, December, January timeframe, with probabilities for above average precip now evident in the southern plains, and even higher probabilities for above average rainfall across the southeast. And much of the same for the December, January, February period. Now, this is not all that surprising given the background El Niño conditions in place, as we discussed, but it at least gives us some hint that there may be enhanced precipitation in the southern tier of the country, perhaps due in part to severe weather events. Now let's take a look at a forecast from the European Model Ensembles of 500 millibar geopotential height anomalies through the winter. We've talked about geopotential height on the channel before. Basically, it's the height of a constant pressure surface, in this case 500 millibars, above mean sea level. In general, lower heights are associated with troughs, and higher heights are associated with ridges. So on this map, the yellows and oranges represent above normal 500 millibar heights, and the blues represent below normal 500 millibar heights. And this progresses using those same 3-month running periods as the CPC precipitation forecast. So we'll start here with the October, November, December period. then November, December, January, and finally December, January, February. Notice what happens as we go through the animation. We start off for the October, November, December period with mostly above normal heights for the entire United States. But by the end of the forecast period, we see an area of significantly below normal heights develop off the U.S. West Coast. Well, since lowered heights are often associated with troughing, this means that we could see a more active jet stream setting up over the western U.S. and eventually taking aim at the central and southern portions of the country. Now remember, this is only one model, but it is interesting to note that this particular model is showing lowered heights developing off the U.S. West Coast, which could mean a slightly more active storm track than expected into the central and southern U.S. All right, let's talk about some possible analogs to the background conditions we're expecting to see this fall and winter. Basically, we're looking for past fall and winter periods that experienced El Niño conditions with a negative PDO. And we can go even further by looking for falls and winters with a strong El Niño, which, as we discussed, is expected to develop as we go into winter this year, and a strongly negative PDO. We're going to disregard the Arctic Oscillation, even though it is a fairly good modulator of tornado activity in the U.S. At this point, again, we just don't know how the AO is going to play out in the months ahead. But as for secondary seasons with both a strong El Niño and a strongly negative PDO, there actually haven't been very many occurrences of this in the past. Brian Bledsoe, who is the chief meteorologist and climatologist at 11 News in Colorado Springs, did some research and found only 3 instances of this in the past: 1951-52, 1972-73, and 2009-2010. All 3 of these secondary seasons had a strong El Niño with a strongly negative PDO. The best of these 3 analogs appears to be 1972-73. During that fall and winter, the ONI peaked around 2 degrees Celsius, representing a very strong El Niño, and the PDO was generally negative and became increasingly negative as winter wore on. October 1972 saw quite a bit of activity from Texas into the Gulf Coast states, especially across the Florida Panhandle, up into Alabama, Georgia, and the Carolinas, with also a few out here in the west across California and Arizona. November 1972, much of the same from East Texas through the Gulf Coast states. December 1972, fairly quiet, couple of tornadoes down there along the Gulf Coast, with a little bit of activity farther north than what might be expected for a typical strong El Niño. Across Oklahoma and Missouri, we saw a little bit of activity. And January 1973 was much of the same. Nice concentration there from central Texas through Louisiana and Mississippi. Another cluster there in central Florida with a little bit of activity, again, farther north than you might expect. Oklahoma into Missouri and far southern Illinois, before having a fairly quiet February with a few tornadoes across the southeast to close out that winter period. Let's move to 2009-2010. The ONI peaked above about 1.5 degrees Celsius, right in that moderate to strong El Niño range. And the PDO was generally negative, although it was not nearly as negative as it is currently. And we actually dipped slightly into the positive territory toward the end of winter 2010. So it's not a perfect analog, but it's still a pretty good one to analyze. October 2009 was pretty active. We had quite a bit of activity in that Arklatex region from East Texas into northern Louisiana and southern Arkansas. We also had some activity across Oklahoma into Tennessee and Kentucky as well. One thing I'm noticing as we go through these analogs is that we have our typical preponderance of activity in the Gulf Coast states, but we also are seeing a little bit farther to the north than what one might expect during a strong El Niño phase across places like Oklahoma, Arkansas, Missouri, Tennessee, Kentucky. We're seeing a decent amount of activity. So that is something to keep in mind as we go into our secondary season this year. On the other hand, November 2009 was extremely quiet, not much activity at all for November 2009. December 2009, your typical Gulf Coast states, tornadic activity from East Texas into Louisiana and the states out to the east. Another thing I'm noticing is that the eastern third of Texas has been quite a hot spot during these analog years, so that'll also be something to keep in mind as we go into the secondary season. January 2010 had quite a bit of activity across those Gulf Coast states once again, East Texas into Louisiana, Mississippi. Also a cluster there across northern Alabama and Tennessee, a little bit farther to the north once again. And also a few out here in California and Arizona. I remember living in Arizona in January of 2010 and being in a tornado warning in the southeast part of the Phoenix metro area where I lived. So definitely seeing a little bit of a signal here in the western portion of the country, California, Arizona, in these analog years as well. And February 2010 was a very quiet month to close out winter 2010. And finally, 1951-52 did not have quite as strong of an El Niño as our first 2 analogs did, but it did have a strongly negative Pacific Decadal oscillation, fairly comparable to what we're seeing now. October 1951 was fairly quiet, just a couple of tornado reports from Oklahoma into Arkansas, but November 1951 was very interesting. We had quite a bit of activity displaced much farther to the north than is expected for typical El Niño years, and compared to what we've seen with our first two analogs. We had quite a bit of activity from northern Alabama into Tennessee and areas farther to the north, including in central and northern Illinois near the Chicago metro, and that continued into December 1951. We had an EF3 tornado in northern Illinois along with our typical Gulf Coast activity. So very interesting to see how far north this activity was displaced, and definitely a trend we've seen with our first few analogs. January 1952, our typical Gulf Coast activity from Arkansas down into Alabama, Georgia, and Florida, with a lone report there up in Pennsylvania. Not sure what that was, probably just an outlier event, I would suspect. And then February 1952, quite a bit of activity, including an EF4 tornado across Tennessee. Pretty much a cluster of activity there across Tennessee, in the northern portions of Mississippi, Alabama, and Georgia, along with a few down in the Louisiana-Texas border region and along the Gulf Coast. If we combine these three analogs and look at the total precipitation anomalies across the U.S. for these 3 years, you can see which areas tended to see more unsettled weather. The blues and greens represent above average precipitation, while the reds and oranges represent below average precipitation. And we notice above average precipitation across California into the desert Southwest, as well as in those Gulf Coast states, but also in those areas to the north that we talked about, places like Arkansas, Tennessee, Kentucky, Missouri. Again, this does not have anything explicitly to do with severe weather or tornado potential, but it at least shows where the stormier weather tended to set up in these analog years. So with all of this being said, what do I think is going to happen during this secondary tornado season? Well, given the factors at play, including the strong El Niño background state, I'm guessing we see a somewhat below average to average number of tornadoes across the U.S. this second season. I do suspect that the jet stream will remain displaced a little bit farther to the south, as is normal for El Niño years, and thus we'll see the majority of activity confined to the Gulf Coast states, so Texas, Louisiana, southern Mississippi and Alabama, Georgia into Florida. But given that we have a very warm Gulf of Mexico and that strongly negative PDO in place, we may see activity slightly farther north than what is typical for El Niño years. Places like Oklahoma, Arkansas, Missouri, Kentucky, into Tennessee, they may see a bit of tornadic activity this coming season. And those factors might help compensate a bit for the tendency for El Niño years to be well below average in tornado frequency. We also might see some surprises out west across California into Arizona. From having lived through numerous El Niño years out there, I often saw a storm system or two that produced a couple of tornadoes here and there during strong El Niño winters. So very well could see a few tornado events out in California and Arizona, but most of the activity going to be confined to the Gulf Coast states and perhaps areas just slightly to the north. As far as how the secondary season might progress, it's hard to say. Given some of the forecast products and analogs that we talked about, I think we'll probably see a somewhat quiet October into November. Maybe a few modest tornado events sprinkled in there, likely confined to the area near the Arklatex into the Gulf Coast. Going into the winter, December through February, we might see a slight uptick in activity, still centered on the Gulf Coast states, but perhaps a bit farther north as well, especially if that European ensemble 500 millibar height forecast comes to fruition. Those lowered heights representing more troughing out here across the western U.S. could represent a slightly higher frequency of tornadoes farther north as well. Oklahoma, Arkansas, the Arklatex into the Ohio River Valley region. But overall, I suspect we'll see a slightly below average season, with the best case scenario being about average, and factors such as how the Arctic oscillation progresses may modulate things down the road. So that's going to do it for this video. Hopefully this gave you a little insight into what factors tend to drive the secondary fall and winter tornado season in the U.S. So with that, thanks for watching, and we'll see you in the next video.